Look at this pale blue dot. From down here on the surface, Earth feels permanent, a perfectly safe home in a quiet corner of the universe. But the geological record proves otherwise. 66 million years ago, a rock from space slammed into the planet and erased the dinosaurs in an instant. If a similar impact happened today, human civilization would end. Keeping our entire species confined to one planet makes our eventual extinction a mathematical certainty. We need an existential insurance policy. To guarantee we survive the long game, humanity has to figure out how to live on more than one planet. Finding that second home requires an audit of our immediate planetary neighbors, but the options dry up quickly. Take Venus, for example. It is our closest neighbor, but the surface temperature sits at 450 degrees Celsius, and its clouds are sulfuric acid. Further out, we have the gas giants like Jupiter and Saturn. You can't even land on them because they lack a solid surface. That leaves us with Mars. A single day there is roughly 24 hours and 37 minutes. It has shifting seasons, firm ground we can build on, and massive reserves of water locked up as ice. It is far from a perfect paradise. Yet, out of all the rocks orbiting our sun, Mars has the exact combination of physical traits we need to even attempt colonization. This orbital map shows the first logistical nightmare. Because Earth and Mars move at different speeds, a launch window only opens every 26 months. Make that window, and you still face a 7 to 9 month commute. And stepping outside isn't an option. The Martian atmosphere is only 1% as thick as Earth's, and it's composed almost entirely of toxic carbon dioxide. Without a spacesuit, a human would be dead in 2 minutes. Then there is the extreme cold. The average surface temperature is a bitter minus 60 degrees Celsius, and it regularly drops to minus 125 degrees. But the most severe threat is invisible. Mars lost its magnetic field billions of years ago, leaving the surface exposed to a constant bombardment of cancer-causing cosmic radiation. Mars is an actively hostile environment that will kill unprotected humans in minutes. Surviving there requires paying a massive premium in human engineering. Establishing a supply chain starts with the high cost of transportation. Fully reusable mega-rockets, which can land and launch again like commercial airplanes, finally make moving massive payloads economically viable. Once there, we can't afford to ship steel and concrete from Earth. Instead, we have to rely on in-situ resource utilization, using giant 3D printers to process the local red soil into immediate building materials. Those structures will need to be buried. Living just a few meters beneath the dirt naturally absorbs the lethal cosmic radiation and insulates the habitat from extreme temperature swings. For life support, robotic drills will extract the vast sheets of subsurface ice. We can drink it, split it into breathable oxygen through a process called electrolysis, and refine it into rocket fuel for the trip home. We also can't farm in the native dirt because it's laced with toxic chemicals called perchlorates. Food will have to be grown inside soil-free hydroponic domes, fed by LED lights and nutrient-rich water. We aren't adapting human biology to Mars. We are engineering a high-tech, sustainable bubble of Earth designed to keep a completely hostile planet on the outside. Over centuries, that bubble could expand. The ultimate goal is terraforming, artificially pumping greenhouse gases into the atmosphere to warm the planet, melt the ice caps, and eventually make spacesuits obsolete. As this diagram shows, Mars has only 38% of Earth's gravity. A human born and raised in that environment will develop distinctly different bone density and muscle mass. Within a few generations, these people will cease to be Earthlings. They will be the first true Martians, representing a new physical branch in the human family tree. It is easy to argue that we should fix our problems here before venturing out. Yet, extreme space exploration historically forces the invention of technologies like water purification and advanced solar that solve critical problems right here on Earth. When you look up at that red dot in the night sky, you are looking directly at humanity's ultimate insurance policy, and perhaps the beginning of our next evolutionary chapter.